Hello there and welcome to today's class. For this class, we're discussing about partial fraction, right? An aspect in mathematics. So we have discussed about several rules that governs partial fraction ranging from rule 1, rule 2. Now here in today's class, we're talking about rule 3. To understand the concept about rule 1 and rule 2, simply check the description of this video. I'll drop the link to rule 1 and rule 2 that guides our idea of solving problem under partial fraction, right? So let's dive into rule 3 that governs the concept of partial fraction. What's rule 3? So note that rule 3 says that if the factor of the denominator are in the form ax squared plus bx plus c. So I'm saying that if the factor of the denominator are in the form, this one here, hence the partial fraction of the form ax plus b all over ax squared plus bx plus c exists. So I'm saying that if the factor of the denominator are in the form this here, so the partial fraction of the form ax plus b all over ax squared plus bx exists, such that this one here, ax squared plus bx plus it plus c, is what? A non-factorizable quadratic equation, right? Quadratic equation. So if the factor of the denominator are in the form this, such that this one here becomes a non-factorizable quadratic equation, hence the partial fraction of the form ax plus b all over ax squared plus bx plus c exists. Let's take a problem to further explain the idea behind rule 3. The example says resolve into partial fraction this question here. Let's try to solve this question here using the idea of rule 3. We said whenever it comes to solving any problem under partial fraction, what's your first task? Your first task, consider what? Your denominator. So solution, my first task is what? Consider denominator. From here, what's my denominator? This one here. I have x to the power 4 plus x squared plus s cubed per se plus 2x squared as my denominator. Observe that this denominator can be expressed. Observe that for this denominator here, I'm having x all through. Let's factorize out x here. So I'll factorize out the one with the least power. I'm having x to the power 4, x to the power 3, x to the power 2. Which one has the smallest power? That's x squared, x to the power 2. So I'll bring out x squared into x squared plus 3x plus 2. I'll factorize this out now. So it means x squared times x squared will give x to the power 4 plus x squared times 3x will give, sorry, there's no 3 here, sorry, I just have one x here, please, x. So x squared times s will give s cubed plus x squared times 2 will give 2s squared. So this denominator now has been expressed in this form. So now observe that x squared plus x plus 2 is not a factorizable quadratic equation. I can't factorize it. You can try it out, check. You can't get any answer to this one. So this one becomes a non-factorizable quadratic equation. So it means that from this point here, to write out the general partial fraction form, I will have this one here, which is x squared plus 2x, x squared plus 2x plus 2x plus 3, right? All over x to the power 4. Next up, plus x cubed plus 2x squared, right? So I have this plus 2x squared is now equal to, now listen, what's my denominator? I have x squared, then this unfactorizable quadratic equation. This is x squared. From the idea of root 2, we said if the factor of the denominator are linear, x alone is linear. But repeated, I'm having x squared. So the partial fraction of this one becomes, for x alone, for this x squared, becomes a over x plus b over x squared. This from root 2, idea of root 2. So plus, this is now a non-factorizable quadratic equation, becomes what the ax plus b. But I've used a, I've used b. So I'll use what the cx plus d all over what? This unfactorizable quadratic equation, which is x squared plus x plus 2. I have this one here. All right, at this point here, what's my next task? My next task, obviously, from here is to what? Is to find my LCM here, right? So it means that if I let's keep this one to prevent us from space. Let's hang on with this. I meant to repeat this one down, but for sake case, I will pen this one now. Let's focus on this. So looking for LCM. For our LCM, what do we know? This is equal to A, B, C, and D are numerator. These are the denominator. So I'll look for LCM from what? My denominator. When it comes to LCM, let's imagine that this one is not there. In between x and x squared, which one let's pick as LCM? The one with what? The highest power. So this becomes x squared becomes my first LCM. Then put this one down to x squared plus x plus 2. So this 2 here becomes my LCM of that one there. So now let's get things right, please. Now from here, x squares, this x squared cancel out x. I'm left with x with this one here. So I'll be having this a, then x into everything here. X squared plus x plus 2. I'm done with this. This x squared cancel out x squared, left with only this. So I'll have this b plus b into everything here. X squared plus x plus 2. Finally, if this one cancel this one, left with x squared. So I'll be having what there? I'll be having plus cx plus d into x squared. So this is what I'll be having here during the simplifying process. So I'll be having this one here. All right, let's proceed, please. From here, what do we get? From here now, from here, if I expand through, right, expanding numerator, yeah, perhaps. From here now, I'll repeat this one. X squared plus 2x plus 3 all over x to the power 4 plus x cubed plus 2x squared is now equal to all numerator, that's ax into x squared plus, or perhaps I can just expand, so to make my work faster, please. Ax times x squared becomes as cubed. Ax plus ax times s give plus ax squared. Ax times 2 becomes plus 2ax. Next up, plus b times s becomes bx squared. Sorry, b times s squared, bx squared, plus b times s becomes bx plus b times 2 becomes 2b. All right, next up, plus 2 x squared times cx becomes cs cube plus d. After expanding everything here, I have all what is here. Then all over, bring out this one down here. At this point, my next task now is to equate numerator. So equating numerator, what do I get? Write out everything here. That's x squared plus 2x plus 3 being equal to ax cubed plus ax squared plus 2ax plus bx squared plus bx plus 2b plus cs cubed plus dx squared. All right, after equating numerator at this point, obviously, what's your next procedure from here? Your next procedure from here now is that I'll collect like terms. All right, collecting like terms, right? What do we get? I'll have that x squared plus 2x plus 3 is equal to, start with the one with s bar. So this s cube. So I'll bring the one s cube together. That becomes as cube plus cs cube. I've taken this one here. After s cube, next one is x squared. Pick this one, s squared, x squared, and x squared there. That becomes plus ax squared. I've taken this one plus bx squared. I've taken this one plus dx squared. I'm still picking this one. After x squared, I'm having the one of x. So this one. So I'll write plus 2ax. That is this one. I'm picking this one. Next up, plus b plus bx. I'm picking this. Next up, left it what? Plus 2b. All right, I have this one here. At this point, my next task is to factorize. Factorizing, what do we get at this point? Factorize is quite simple. I'll have x squared plus 2x plus 3 being equal to s cubed. True or false? True. I'll have a plus c into s cubed. Bring out this s cubed outside, then take a plus c inside. So a times s cubed give as cubed. C times s cubed is cs cubed. So plus this s squared. That becomes a plus b plus d. That becomes a plus b plus d into x squared. This is for x. That becomes plus 2a plus b, 2a plus b. Then I have x there. Next up, plus 2b. I've just factorized at this point. So obviously from here, what's your next task? My next task is what? Compare coefficient. Comparing coefficient. What do we get? All right. Comparing coefficient. What do we get? When it comes to comparing coefficients, start with what the one I star. For this expression here, I'm having s cubed, x squared, and x, and a constant. So start with the one I star. So cube. What's the expression? Check this left hand side. Is there my expression with s cube? That's a plus c. I'll have a plus c. Call this one equation 1. After calling this one equation 1, what's your next task? I'm done for s cube. So So this is for x cubed. Next up, for x squared now, I get, check for your x squared, check the one with x squared. Check this equation here, everything here. Is there of x squared? This is x squared. What's the coefficient of x squared here? That's 1. So that becomes 1. I'll have 1 to be equal to, check for x squared here. What's the coefficient of x squared? A plus b plus d. So I have a plus b plus d. Call this one equation 2. Alright, this is for x cubed, x squared. For x now, what do we get, please? For x, the coefficient of x here is 2. That becomes 2 is equal to, for x, that's 2a plus b. I have 2a plus b. Call this one equation 3. Alright, for constant now, for constant, what do we get? Constant is 3, yeah? That becomes 3 is equal to, what's my constant here? 2b. I have 2b as my constant, equation 4. Alright, clearly, let's start from equation 4. So I'll solve this equation simultaneously. So from equation 4, is clear that 3 is equal to 2b. So we can easily get b here. To get b, divide here by 2, divide here by 2, divide here by 2. So b, therefore, b is equal to 3 over 2. I've got the value for b. Next up, I'm looking for a, b, c, and d. So I've gotten b. I can easily put b here to get a. So put b as being equal to 3 over. At this point here, I'll put b as being equal to 3 over 2 into equation 3 to get a. So therefore, I'm having 2 to be equal to 2a plus b from equation 3. I'll try to make a subject. How? Take this one here. I'll have 2 minus 2a as being equal to b. Something is common here, right? That's 2. So we got 2 into 1 minus a as being equal to b, right? Or perhaps better still, I can take this one here. That becomes minus 2a is equal to b plus 2, right? Take this 2 here. That's b minus 2 instead, because this is a plus 2. Come become minus 2. So I want to make a subject divided by minus 2. I'll have that a is equal to b is equal to minus. This less minus common. Minus is not proper for minus to be down. So take minus up. That becomes minus into b minus 2 all over 2. So let's put the value of b, this one, inside here, and let's get a. So I'll not clean this expression because my answer will be in this expression, in this form. So to record this form, I don't need to clean it. So let me just leave it here. Let me just leave this one here. So I'll clean this one. I'll eliminate all this one here. I'll eliminate all this one here. Okay, I'll keep this one here pending. Alright, at this point here, I'm saying that a now is equal to minus into b. B is what? 3 over 2, right? 3 over 2. So minus 2 all over 2. From here, I'll be having minus into this is an invisible one here. So LCM here is 2. 2 in 2 is 1. 1 times 3 is 3. Next up, 2 in 1 is 2. 2 times 2 is 4. So minus 4 all over 2. From here, a is equal to minus into 3 minus 4 is minus 1 over 2. all over this 2. Minus minus is plus. That becomes 1 over 2 over this 2, yeah? Divide this 1 here, that becomes 1 over 2. This is division divided by this 2. Apply the law of reciprocal. A is equal to 1 over 2 times, there's an invisible 1 here. This 1 comes up first, then this 1 comes down. So from here now, therefore from here, A is equal to 1 over, at this point, I've got the value for A as 1 over 4. So at this point now, my aim now is that I've gotten A, I've gotten B. Let's get C. To get C, I can observe from equation 1 that C is there. So I'll put the value of A into equation 1. Then this is my equation 1 here. I'll take A here. I have minus A is equal to this C. So minus, what's A? 1 over 4. Equal to C. So it means that C is equal to what? Minus 1 over 4. So now my next task now is to get, I've got the value for A, B and C. Let's get D. To get D, D only exists in equation 2. So I just need two things, A and B, to get D. So I'll put the value of A and B into equation 2. This one here. What's equation 2? I have that 1 is equal to A plus B plus D. True or false? True. Let's get D. I'll take this D, this one D, come here. I'll have that minus D is equal to, if this D comes here, right, become minus D. This one coming becomes minus 1. That becomes A plus B minus 1. Take this minus D here. Alright, let me use this way. I'll have this 1 here. This one coming because minus D is equal to A plus B. Right? This 1 is this 1. Take plus D here. I'll have minus D is equal to everything here. Take this 1 here now. I'll have that D is equal to A plus B minus 1. So D now is equal to what's A? A is 1 over 4 plus what's B? B is 3 over 2 minus 1 all over invisible 1, right? This minus 1 is this. Just add invisible 1 there. So all over, my LCM is 4. 4 in 4 is 1. 1 times 1 is 1. Minus 4 in 2 is 2. 2 times 3 is 6. Minus 4 in 1 is 4. 4 times 1 is 4. So D is equal to this expression. So 1 minus 6 is minus 5. Minus 5 minus 4 is minus 9 all over 4. So it means that D is equal to minus 9 over 4. So I'll put A as equal to 1 over 4, B as equal to 3 over 2, C as equal to minus 1 over 4, and D as equal to minus 9 over 4 into partial fraction general. So I'm saying that at this point I'll put a value of A, B, C and D into partial fraction general form. What general form that we know? This is here. So I'll rewrite this one down back here. So for better understanding, let me write it here. So I'll discard this one. So from here, write this one. I'll have that x squared plus 2x plus 3 all over x to the power 4 plus x cubed plus 2x squared is equal to a over x plus b over x squared plus cx plus d all over x squared plus x plus 2. So I'll put a as 1 over 4, b as 3 over 2, c as minus 1 over 4, and d as minus 9 over 4. So I'll have what's it called? Let me. It's proper for me to repeat this one down, but for clarification, let me pen it first. So I'll have this a as 1 over 4 all over x plus what's b? B is 3 over 2 into over x squared plus what's c? Minus 1 over 4 x, please, there's x there, plus what's d? Minus 9 over 4 all over x squared plus x plus 2. From here, I'll take this 4 down, take this 2 down. It's as accepted in mathematics. So I'll have that instead of if I put 4 down, that's where it will end up. Look at, I'm having 1 over 4 divided by this x. This becomes 1 over 4 times 1 over x, 1 over 4x. So it's more of like saying shift this 4 down. That's the shortcut. At this point now, I'm saying that this 1 is this 1 here. Take this 4 down, 4x. This 3 here, take it 3 here. This 2, bring it down, becomes 2x plus at this point here, minus 1 times x is minus x all over this 4 plus minus is minus 9 over 4, then all over everything here is this. So from here now, what's next? I'll have 1 over 4x plus 3 over 2x squared. They are of the same denominator, so this is plus into the same denominator. What do you get? Bring this together, that becomes minus x minus 9. Observe please, minus x minus 9 all over 4, since they're the same thing. So next up, perhaps I can take it this way, all over 4. So I have this then all over x squared plus x plus 2. So factorize out x. X is common here. So I'll be having 1 over 4x plus 3 over 2x squared plus minus into x x plus 9. So minus times x is minus x, minus plus 9 is minus 9. So all over 4, right? Then divide by this last expression, x squared plus x plus 2. Plus minus is minus, right? So I'll be having, this is 2 here. So this one I'll be having my expression as 1 over 4x plus 3 over 2x squared plus minus is minus, then x plus 9, right? All over, take this 4 down. That becomes 4 into x squared plus x plus. So my next task now is to repeat this expression, right, that I penned earlier, then equate it to what's it called, my answer here. So I have this as my answer. So alright guys, I observe something please. Look up please. There's a positive sign here, right, and I end up writing negative here, so it's a mistake. So I'll have a plus here. So 1 plus 6, that's 7. 7 minus 4 is 3, right? That's 3. That's 3, right? That's a 3, positive 3. This becomes 3 here. 3 over 4. So I have D as 3 over 4. 3 over 4, right? So here will be what's it called, plus, right? Here will be plus, here will be 3, right? Minus 1 times x minus x, then plus this 3 here, so it becomes minus x plus 3, right? Minus x plus 3. From here I'll have, what's it called, I'll bring out this x plus 3. I mean plus 3. So I'll change this one here to 3. So here it becomes 3. So it's like the error we are trying to correct. So those are solved three problem under the idea of row 3, using the idea of partial fraction